I want to do one question on projectile motion where the object is launched at an angle, reaches a peak height, and then comes back down and lands on the same level as it started. Maybe you're kicking a soccer ball, maybe you're kicking a football, maybe, I don't know, maybe you're driving your car and then you hit a deer like I did 2 hours after I got my learner's permit, and the deer flies through the air, becomes a projectile. I don't know what it is. Okay, bottom line is it's launched from ground level at an angle, comes back down and hits ground level. Okay, we want to know two things from this. We want to know how far down the road the deer hits, and we want to know what its maximum height is, or how far downfield the soccer ball hits, or what the maximum height of the soccer ball is, whatever it is, right? How do we do that? Well, everybody knows what the first thing we should do is. You look at this question, and everybody, whether you were here or not last week, can see something in this question that's familiar to you. What is it? Yep. It's a funny angle, and we don't like funny angles, so we got to get rid of it. So let's go off to the side and get rid of the funny angle. This question doesn't look at all like the questions we did involving displacement, right? Walk 10 meters, walk 20 meters at 30 degrees south of west, and so on. What's the displacement? Doesn't look at all like those questions, except that we have a funny angle. That's the only thing that it has in common, at least at this point, the only thing that it has in common. You know what? That's enough. Let's do the same thing to that funny angle as we did with those other questions. Draw it off to the side, label an x component and a y component, and let's find the x component and the y component. Let's say cosine 30 degrees is equal to adjacent over hypotenuse. X ends up being equal to 17.32 meters per second. Sine 30 degrees is equal to opposite over hypotenuse. Y ends up being equal to 10. So now what we're saying is that the x component of the initial velocity is 17.32. The y component of the initial velocity is 10 meters per second. Now we don't have any funny angles. That whole 20 meters per second, the whole 30 degrees is gone. It's completely gone to us now. We'll never use that again. Now we got to go to our x's and y's. Now for those displacement questions, we said, we looked at all the vectors we had, and we added up all the different x components and all the different y components. We're going to treat this a little bit differently. We're still breaking it up into x and y, but now we're going to put two equations in, an equation for x and an equation for y. What do you want to use for x? What's the equation that we always use for x in these projectile motion questions? Good. V is equal to delta d over delta t. That's a group A equation, right? It infers constant velocity. That's why we use that equation, because this problem horizontally involves constant velocity. There are no forces acting horizontally. There's one force acting vertically, it's gravity. Nothing acting horizontally, so there's no reason for it to speed up or slow down horizontally. Hence constant velocity. On the y component, there is gravity. It is accelerating on the y-axis. It's slowing down as it goes up into the air. It's speeding up as it comes back down. Speeds up as it goes back down. It's an acceleration problem. We're going to use one of the 5 acceleration equations. The one that we'll likely use, the one that we're almost always going to use, is VIT plus 1/2 AT squared. Why that one over the other ones? It tends to work the best. That's it. Through trial and error, doing thousands of these problems over the years, that's the one that works the best. So let's try that one first. Now we just plug numbers in, see what happens. What's the x component of the initial velocity? How much of this 20 meters per second is x component? What do you say there, Everett? What's the x component of the velocity? Good. 17.32. We don't know the displacement and the x-axis. We don't know the time. All right. No big deal. It wasn't a help, but it's no big deal because it probably will be a help later on. Let's go to the y component. Do we know the y displacement? The change in position on the y-axis? And do we know that one? This is where it starts on the y-axis. This is where it ends on the y-axis. What's the change in the y-axis position? 0. It starts on ground level, it ends on ground level, so the displacement is 0. In those other problems we did where it was launched off the edge of a building, it ended up below where it started, so we made the displacement negative some. What about VI? VI for the Y component. Taylor? Was your hand up? No? All right, you can answer it anyways. That's what you get for moving, though, and breathing the wrong way. You called on. What's the Y component of the initial velocity? It's 10. Yeah, 10 meters per second. Times time plus 1/2 of neg 9.81 times the time squared. Now, what I like to do here is simplify this a little bit. 0 is equal to 10 times time, subtract 4.905 t squared. All that is a half times neg 9.81. Now, let's take that entire term over to the other side. Simplifies it a bit more. Take it by adding because it's subtracted on the right side. And then we divide everything by t. And the t on the right side disappears. One of the t's on the left side disappears. We get 4.905 t equals 10. And t ends up being equal to 10 divided by 4.905, which is 2 point something. .03874 seconds. I mean, there's how long the ball, the deer, whatever it is in the air for. Let's plug that in over here. And then let's take the 2.04 up by multiplying. And we get 35.3. Should round it 2 digits, 35 meters. So how far does the ball go? 35 meters. All right. Now, the second part of that question is, what's the max height? We went over this on Thursday, learning how to solve for the Thursday or Friday? Friday was. Solving for the maximum height of the ball in this projectile, this parabolic path. Does anybody remember how to do it? Is your hand up? No? Okay, what do we do? We do what, sorry? Okay, for the Y component, right? So we're still doing the Y component because, look, if we're finding maximum height, that's a Y-axis thing, right? So deal with the Y component, but use VF squared is equal to VI squared plus 2AD. Tell me, somebody else, tell me what VF is at maximum height for the Y-axis here, Emma? 0. So if we're analyzing only the trip up on the Y-axis, VF is 0. VI would be 10 because it's the initial Y velocity, the initial Y speed, I should say. It becomes negative 100 equals negative 19.62 times delta D. Delta D becomes 100 divided by 19.62. Which is 5.1. We've just found a vertical displacement. That vertical displacement is the displacement at the time when the vertical velocity becomes 0. When does the vertical velocity become 0? When it's at its maximum height. So we've just found the maximum height by doing this.